The James Webb Space Telescope is a powerful tool for observing the universe. With its advanced technology and state-of-the-art instruments, the telescope can see further into space than any other telescope before it. One of the major goals of the James Webb Space Telescope is to observe the farthest galaxies in the universe. These galaxies are so far away that their light takes billions of years to reach us, giving us a glimpse into the distant past. In the recent months, all of you might have seen multiple articles about records being broken for the observations of the most distant galaxies. These discoveries have baffled scientists for the past few months and have shattered many beliefs about the evolution of the universe. So how is James Webb constantly making observations to the farthest galaxies known? What questions do these new discoveries both answer and give birth to? Let's talk about all of that and more. The James Webb Space Telescope is equipped with a suite of advanced instruments that allows it to make detailed observations of the universe. One of the key instruments on the telescope is the near-infrared camera, or NIRCam, which is designed to detect light in the near-infrared range of the electromagnetic spectrum. The near-infrared range is particularly important for studying distant objects in the universe, as it is the range of light emitted by many of the oldest and most distant objects in the universe. This makes NIRCam an ideal tool for observing galaxies that are located far beyond our own Milky Way. In addition to NIRCam, the James Webb Space Telescope also has near-infrared infrared spectrograph, also known as NIRSpec, that is capable of making detailed spectroscopic observations of distant objects. This allows astronomers to study the chemical composition and physical properties of distant galaxies, providing valuable insights into their formation and evolution. Another key instrument on the James Webb Space Telescope is the mid-infrared instrument, which is designed to detect light in the mid-infrared range of the electromagnetic spectrum. This range is important for studying the warm dust and gas that are found in galaxies, as well as the formation of stars and planetary systems. Together, these instruments give the James Webb Space Telescope a powerful set of tools for studying the universe. They allow the telescope to see objects that are too faint or too distant to be seen by other telescopes, providing valuable insights into the distant reaches of the universe. One of the major advantages of the James Webb Space Telescope is its ability to make observations in the infrared range of the electromagnetic spectrum. This allows it to see through the dust and gas that often obscure objects in the universe, providing a clearer view of distant galaxies and other objects. Other advantages of the James Webb Space Telescope is its location in space. Unlike ground-based telescopes, which are limited by Earth's atmosphere, the James Webb Space Telescope is located in a stable orbit around the Sun. This allows it to make observations that are free from distortion and interference caused by the Earth's atmosphere. Overall, the advanced technology and sophisticated instruments on the James Webb Space Telescope make it an incredible, powerful tool for studying the universe. Its ability to see distant objects in the infrared range, combined with its location in space, allows it to make observations that would be impossible with ground-based telescopes. This makes the James Webb Space Telescope a valuable asset for astronomers, and we can expect many exciting discoveries in the years to come. Using these cutting-edge instruments, James Webb began observations of the universe's most distant and oldest galaxies. Almost everyone has seen the first James Webb images and marveled at the incredible views of the infrared universe that the telescope was designed to study. This image released by James Webb, which can be found on Webb's website, shows the potential of James Webb. While there are many more early release photos in the pipeline, the first academic articles are starting to appear. As predicted, investigations of faraway galaxies are already making headlines. The first most distant galaxy to be observed by James Webb was the galaxy called GNZ11, which is located in the constellation Ursa Major and is estimated to be around 13.4 billion light-years away from Earth. To put this distance into perspective, consider that the light from GNZ11 began its journey towards us when the universe was only a few 100 million years old. In other words, the light we are now seeing from GNZ11 was emitted when the universe was in its infancy. The galaxy was discovered by a team reviewing data from the Hubble Space Telescope's Cosmic Assembly Near-Infrared Deep Extragalactic Legacy Survey, or CANDLES, and the Spitzer Space's telescope Great Observation Origin Deep Survey North. The researchers used Hubble's Wide Field Camera 3 to determine the distance to GNZ11 spectroscopically, detecting the redshift caused by the universe's expansion. The findings, which were announced in March 2016, show that the galaxy is farther away than was thought before. It is getting close to the edge of what Hubble telescope can see. Thanks to James Webb Space Telescope and its high-resolution infrared equipment, astronomers can now see the oldest epochs of the cosmic history. Of course, the Hubble Space Telescope played part in all of this as it gave the first glimpse of the galaxy GNZ11. The observation of GNZ11 was made possible by the James Webb Space Telescope's powerful infrared instruments, which are able to detect light from distant objects that is too faint to be seen by other telescopes. This allows the telescope to see objects that are otherwise invisible to us. The discovery of GNZ11 is a significant step forward for astronomers because it sheds light on this early universe and the formation of galaxies. It also helps to confirm theories about the universe's expansion and the role of dark matter and dark energy in its evolution. The observation of the furthest galaxies don't stop here. In the coming few months after the first observations were made, new possible candidates started popping up. Using the James Webb Space Telescope, scientists discovered two potential candidates for the most distant galaxy ever observed. Both were discovered in the midst of a flurry of early data that was uploaded online as preprints in the week following the telescope's scientific operations beginning in July. Following a thorough inspection, including a re-evaluation due to revised telescope calibration, the data is now amongst the first James Webb Space Telescope discoveries on the early universe to be published in peer-reviewed studies. Researchers must yet validate these galaxies' distances by analyzing the spectral features of the light they produce. However, if preliminary calculations are true, the light from these objects has traveled such large distances that it appears as though it did so 350 million to 450 million years after the Big Bang. These discoveries, together with other James Webb Space Telescope results, suggest that the galaxies began and developed earlier in history of the universe than astronomers have previously been able to investigate. The galaxies in question are Glass Z12, which was found 350 million years after the Big Bang, and Glass Z13, which was identified just after 4 days of analysis as part of the Grimm's Lens Amplified Survey from Space, or GLASS, observation program. The incredibly distant galaxies were discovered in light that had been gravitationally amplified by a bulk of nearby galaxy clusters. The two observations overlap with the previous Hubble record holder, galaxy GNZ11, believed to have been formed just 400 million years after the Big Bang. The ages of the newly found galaxies have not yet been completely validated. Further spectroscopic study is needed. But scientists said the scans indicate strong hits of multiple possibly older galaxies, which would push star formation even closer to the Big Bang. The two finalists for the most distant seem tiny and brilliant, indicating that they were compact, disc-shaped objects rather than diffuse and straggly like many of the faraway galaxies discovered by the observatory. Their orderliness and brightness suggest that the early galaxies had formed well-organized structures out of numerous stars, rather than being deformed and weak as previous Hubble Space Telescope investigations had shown. These galaxies live in an epoch that has mostly gone undiscovered. As a result, the group of astronomers suggested that James Webb searched the light galaxies in the first few hundred million years after the Big Bang, a Z greater than 10 redshift. This study was completed as part of the James Webb Early Release Initiative, and the investigation will most likely continue for some years. The two galaxies, GLZ11 and GLZ13, were discovered to be billion solar mass galaxies. That's rather astounding considering their existence in the early universe, particularly given that the first stars formed 1 to 200 million years after the Big Bang. These galaxies are also bright enough for scientists to do further spectrographic investigations to learn more about them. Computer modeling suggests that these galaxies are tiny and may have disks despite their young age. Based on early James Webb Telescope observations, it seems that GLZ11 and GLZ13 contain a population of hot, young stars, which would be extremely luminous and ultraviolet, and that each galaxy may be bursting with star formation zones. These stars and areas should be excellent candidates for follow-up studies with the near-infrared spectrograph on James Webb Telescope. Furthermore, future spectrum analysis of these distant galaxies might aid astronomers in determining specific ages. Many more James Webb Telescope distant galaxy candidates are still going through the peer review process. Some may be able to break the new redshift record of 12.4. This finding has an exciting consequence that these two distant galaxies in the early universe may just be the tip of the iceberg. There might be many more anywhere James Webb searches. Remember how excited everyone was when Hubble Space Telescope conducted its first deep field study? It pointed to what seemed to be a relatively empty portion of the sky, curious about what was out there. The investigation showed faraway galaxies as far as the Hubble Space Telescope could see. Other deep field studies in the sky in the other direction yielded the same conclusion. It turns out that the cosmos is made up entirely of galaxies. So if these two galaxies are any indicator, James Webb is poised to blow apart our understanding of the baby universe in the same manner that Hubble Space did with its deep field observations. Of course, scientists will use spectroscopy to confirm these galaxies. And if what they predict pans out throughout the sky, the finding of at least 2, and maybe more galaxies, with redshifts ranging from 11 to 13 in every direction that James Webb looks, then we're in for some fascinating times. This magnificent infrared observatory, at the very least, is pushing the cosmic frontier considerably further out, peering beyond what we presently know. In the near future, it may be able to see all the way to the Big Bang itself. In addition to these observations, the James Webb Space Telescope will also be able to study the galaxies in greater detail, allowing astronomers to learn more about their properties and characteristics. This will provide even more information about the early universe and the formation of galaxies. Overall, the observation of these distant galaxies by the James Webb Space Telescope is a significant achievement that will help us better understand the universe and our place within it. As we continue to observe the distant reaches of space with this incredible telescope, we'd expect many more exciting discoveries in the years to come. So what do you think about these intriguing observations by the James Webb Space Telescope? Let us know what you think in the comments section below, and share the video with your friends.